Good morning, everyone, once again, and welcome to the carbon reduction and electrification stage for the sessions on clean cooking. So, we have had the technological innovations part of the clean cooking session in the first 2 hours. So, here we are again for the policies and incentive schemes domain. We have a very selected number of panelists today. And without wasting much time, I would like to call Mr. Ajay Bhagat, who would be presenting on replacement exchange scheme of conventional hot plates with energy efficient hot plates. Mr. Bhagat is a Deputy General Manager with Bharat Petroleum Corporation and has more than 3 decades of experience in LPG operations, logistics and marketing. He has been instrumental in driving rural energy access initiatives, including the award-winning Ujjwala Shakti program, which empowers women entrepreneurs and promotes clean cooking fuel programs. So I welcome Mr. Bhagat for his presentation.
Thank you. Sabu Saab, my fellow speakers and the audience, very good morning. This looks very similar to the office presentation. So I'm surprised. Probably the incentive schemes are not so incentivized, and that's how the the attendance number is. Yeah. So the context is that the most common source of energy being used in the residences is cooking energy, and that varies from the wood to fossil fuel to electricity and biomass, etc., etc. So we will concentrate strictly on cooking gas. Conventional LPG stoves are designed, even though as compared to Europe and other parts of the world, in India they are designed at 68% efficiency, but still during the usage the efficiency goes down, and that is how the consumption goes up. So the problem statement, what if we increase the efficiency, thereby reduce the consumption, and that is what I am going to present on. The objective is to replace the conventional hot plates with the energy efficient hot plates. And you know, in India there is a trend, replacement means you have to incentivize, you have to get something against the earlier one. So I tried working on this part. The current scenario is that in India we have 33 crore plus connections. Every day they are increasing. We recently had 25 lakh quota from Government of India for poor people, and that is about to get exhausted. So from this 33 crore, if I remember correctly, 10.3 crore are Ujjwala, and they are still increasing. Another 15 lakh added to it. Balance are non-PMUI, that is regular connections. The consumption of Ujjwala customers is average 5.12 cylinders in a year. So 10.43 crore customers consuming about 5.12 cylinders in a year, that makes some 52 crore refills per annum. And non-PMUI consumption is 6.89, say for ease of calculation, 7 cylinders per annum. For another say 23 crore customers, that goes whopping something like 158 to 160 crores. These many refills, these many kitchens, if I have to explain the number in terms where it is understandable, we are selling something like 60 lakh refills per day. So 60 lakh homes are getting energized every day. And if we scale up, वो बोलते हैं ना बूंद बूंद से सागर भरता है, तो बूंद का number is specific and it is very high, even though the size of that droplet is very small. So old stores traditionally work at, they are designed at 68%, but as the aging happens, it is not cleaned properly, etc., etc. So the efficiency goes down to as low as 50 to 60%. Bharat High Star is a stove designed by our corporate R&D and my eminent colleague and just like my younger brother, Mr. Analyst Kulkarni, is sitting here. He is a man behind, scientist behind that invention. This is designed as per IS code, but we have done some modifications. The modifications are given here. The primary modifications are that the traditional hot plate, there's a jet from where LPG comes in, and with the Venturi action, the air is sucked inside. It is mixed in the mixing tube, and it comes to the burner. And then when we lit the stove, it burns. Whereas in this particular case, it is so optimized that the mixing happens at an optimum level. Then the number of holes in different manufacturers have their different way of making the top brass burner, and the number of holes are not specific. Over here, we have designed the diameter of the holes and the number of holes in such a way. These are about 130 holes in one burner, and that is how the efficiency goes up. Another thing is, another modification is that the traditional hot plates you see in our homes have 4 angles on which the pot rests. Over here, there is an annular ring which sits on the stove bed and on which there is a pot kept, so no heat is going outside the pot surface. So entire heat is absorbed by the base of the pot. That these 3 modifications are done. These are patented by BPCL. The patent is granted in 4 countries and 14 other countries. It is pending. We have also done taken trademark of approved trademark of Bharat High Star. So this is named as Bharat High Star. Now we are talking about numbers. The older stove, say about 10-year-old stove, if not maintained properly, goes as low as 45 to 50% efficiency. And if we replace that stove with the energy efficient stove, the saving can be per annum anywhere between 2.6 to 5.3 depending on consumption. So when I said the consumption of non-PMI customer is 7 cylinders per annum, there are customers who consume about 12 to 15 cylinders per annum. For those customers, the saving can go as high as 2 to 5 cylinders. Second case, the 2 to 5 years old stove. Say for example, the Ujjwala customer who had taken connection in 2016-17 when it was started, and now if she replaces the stove, even her consumption would go, she would be able to save another 1 to 2 cylinders. Regular new, brand new stove, if I buy from the store, which is designed as per IS, it is designed for 68% efficiency, and that is replaced with the energy efficient stove. Still, there would be a saving of almost 1 cylinder. So, with that, the saving is quite high. Now, this is technical stuff, but what did we do? The incentivization part, the policy matter. Before that, this has a potential of reduction of 1.7 million tons of LPG per annum. The numbers I have told, we sell something like 60 lakh cylinders per day, and if we multiply that 365, the cooking doesn't stop any day. Holidays maybe we are working and the cooking is also going on. So out of 13 SDGs, if we do this, scale up this project, we will be able to touch 2 SDGs, that is affordable and clean energy, and second is climate action, because it reduces the carbon oxide, CO2. Now this is the magical part which we did. The earlier part was earlier explained by my colleague, and I just did the repetition. How did we come out with the stove? This is a typical organogram structure of Bharat Petroleum, where there is a region headquarter, below that is territory office, and we have such 56 territory offices, under which there are about 150 sales areas. The sales officers are actually monitoring the working of the distributors. There are 6,213 distributors as on date who are distributing cylinders in the market, and they place orders which flows through our portal to the territory office. The territory office approves that, and it goes to the vendor. The vendor then executes the order, dispatches the stores through C&F agent to the distributor, and in turn distributor hands it over to the sales it to the customers. Now, the basic question would come to anybody's mind: why should I change my existing stove? So one part is that if the stove is changed, at least one cylinder per annum will be saved. So सीधे सीधे 800-850 रुपए का तो फायदा यहीं पे है. Over and above that, the adoption cost. So we said, if you give us your old stove, which if you sell to the scrap vendor may not give you more than $100. But over here we are giving 600 rupees as an exchange value. So the stove basic model, which cost about 2,600 rupees, if it is exchanged, it will be straightforward discounted by 600 rupees to 2,000 rupees. And why should the distributor do this? So we said, okay, distributor is also incentivized. Similarly, my territory manager may say, I'm anyway getting salary, why should I do this? So territory managers and sales officers are also incentivized, but not monetary way, because it is not permitted. So we have a system called kudos in BPCL, where appreciation letter by none less than the chairman and the directors and executive directors, depending on what kind of work is done by an individual officer, is handed over, and that goes in their CR. So this is again a non-monetary benefit. So again, incentivization. So in the entire value chain, everybody who is touching the entire chain is incentivized, and that is how we are somewhere or the other touching the policy and incentivization goal, which is for the discussion today. Now, another human angle: who does the exchange? What do you as a consumer, who do you see the face of Bharat Gas? Is the delivery man who brings the cylinder at your residence. And if that guy says, no, I will not do it, nothing will happen. So the old stove, which is returned by the customer, is sold in the scrap. Whatever value is received is handed over to the delivery man who does the exchange. In addition to that, 300 rupees is given by manufacturer as an incentive to the delivery man who is carrying out an exchange. So if that guy is getting per exchange, say around 400 to 500 rupees, why shouldn't he do? On one cylinder, the distributor gets about 72 rupees. Out of that, around 20 to 30 rupees is given to the delivery man for executing the delivery. And for one cylinder, if he gets 30 to 40 rupees, or for one stove, he gets straightforward 500 rupees, is the multiplier is good enough for a sizable incentive. So this is how, and the resultant is within 3 months of last year's last quarter, when we did run the scheme, we sold, say in about 70-75 days, 1.8 lakh hot plates of energy efficient, and this year about lakh till now, and we still have about 2 months to go. So this is how it is scaling up. But as of now, we are only selling the stoves for which the customer has to pay. Now, how if we exchange that free of cost, or maybe further incentivize, further discount? As of now, I am giving only 500 to 600 rupees discount to the consumer. How about I am giving Ujjwala customer the basic hot plate free of cost? Yesterday only I was talking to a couple of people in various halls, where two different persons came up with the idea. They said, whatever you have done, it will have a carbon impact reduction, and if we convert that into carbon credits, probably this has, I have not yet calculated, but this is an enormous potential of gaining carbon credits. And if those carbon credits are sold in international market, and even if I take, say, $10 to $20 per credit, and if I convert that into Ujjwala customers' numbers and then hand it over to them, it will have sizable impact. Say even if $20 would mean 2,000 rupees, so 2,000 rupees ka chula. Abhi basic hot plate costs about 1,600 rupees to the manufacturer. If I tell the manufacturer this is a social cost and I will reimburse your cost, probably will be able to do that free. And that if it is done pan industry, BPC, HPC, IOC, I think we have won the war. 10 crore customers, we have huge potential. And this is what the today's subject was. Thank you very much for patient listening.
Thank you very much, Mr. Bhagat. A very interesting session, and we have been associated with BPC very closely for implementation of these goals. And it's very interesting to see how many SDGs all these measures are hitting. He mentioned 2, but I believe ultimately at least 9 out of the 17 SDGs will be hitting when we adopt these clean cooking measures. The next session is mine, so I wouldn't like to introduce myself, so I think I would like to go directly into the presentation. As you are all aware, LPG is a predominant cooking system in the country. Especially in domestic scenario, there is no, currently at least in India as of now, there is no alternative to LPG. Even though electric stoves, biogas and solar have all made inroads into this, however the inroads have been very limited. The commercial cooking environment is something which doesn't get that much attention, merely because compared to the domestic cooking ecosystem, the volumes consumed in commercial cooking systems are very low. In India, especially if you look at the LPG consumption, the domestic LPG consumption remains very high. However, the commercial cooking ecosystem is very sensitive to prices. It is very sensitive to any fluctuations in the availability or all other factors, unlike your domestic cooking system, which are much more insulated and supported by the government. Dimethyl ether, as you might be aware, is currently derived from fossil fuels. However, there is also a separate pathway to DME, the RDME, the renewable DME, which is from the biomass. So DME is currently in discussions mainly as a blending component to LPG. All of you may be aware that the World LPG Association has been renamed as the World Liquid Gas Association, primarily because they are looking into other molecules apart from LPG as a part of their package. So DME comes first in their calculations, and DME has also already been taken as a separate molecule which can be blended with LPG. As far as India is concerned, of course, a lot of discussions are going on, a lot of studies are going on. LERC has done a very detailed study, which is now with the ministry. So anyway, that is the blend is a different discussion altogether. However, dimethyl ether as a standalone fuel can also deliver good performance in domestic as well as commercial systems. So as you can see, the commercial production is still on, even though the volumes available in India are relatively low and are methanol based. So because of the current focus on the methanol economy, and as you might be aware, methanol is now being used in a lot of ships for their engines. So there is a lot of focus on methanol, and DME would be a derivative of methanol. It would be basically dehydration of methanol. So the current project is basically on commercial burner, which works purely on DME, and whose performance is relatively compatible to LPG commercial burners. So we have been working with Niti Aayog and the National Chemical Laboratory on this. So we have already designed, and in fact we have tested this commercial burners. So in India, the LPG commercial burners usually delivers around 35% to 40% efficiency. LERC has a 65% efficiency burner, which is currently getting commercialized. Compared to those available burners, the LPG burners which are currently available in the market, the DME commercial burners deliver a much higher efficiency and almost 55% of thermal efficiency. So, and the advantage here is that the DME, being an ether, has already an oxygen molecule in it, and thereby the emissions are relatively less. It is a non-toxic fuel, and it is being produced from natural gas, coal, or, as I said in the beginning, biomass. The biomass would be the optimum solution, but we are still working on it. The scientific community or the technological community is still working on it. However, compared to LPG, it has lower emissions. So, the components of the DME commercial burner itself are not that complicated. However, there is a lot of research gone into this. So, yeah, the pipe, the injector jet, and the gas inlet, all of them are undergone extensive modifications purely for DME. The other major components are the burner support plates, the pan support, and the angular burner plating. Currently, there is no standard available in India on this. So, LERC being part of the standard making body also. So, we are now currently formulating a standard for this. There are international standards available. The burner design also has been changed. The commercial burner which are ordinarily available in the market are all focused towards LPG. So we had to make a lot of modifications in the DME burners, primarily because the oxygen molecule in the DME doesn't need that much air as is needed for LPG because of the oxygen molecule in the DME. So this is the exploded view of the torch type burner, basically for DME. This is a comparative performance between an LPG commercial burner and a DME commercial burner. The calorific value obviously is high for LPG. Being a through and through LPG man, I would always push LPG, canvas for LPG. However, the fact remains that the availability of LPG in India is very limited, and we are importing 70 to 80% or even more than that of our requirement. So hence the requirement for exploring all these alternative fuels. So DME, once it comes from biomass, would be the renewable path would be a major game changer because it will help us supplant LPG in many of the fields. The flame stability is very high compared to LPG. The primary air requirement is low for DME compared to LPG again. The thermal efficiency of the current LPG commercial burners are low, as I said in the beginning. However, we are working on it, and I am sure it will go up in the future. The combustion efficiency of both are comparable. The soot formation is very low, and heat transfer is more or less comparable. So these are the comparisons. Performance at high altitude is much better for DME, again primarily because of the oxygen molecule already available in the compound. These are the other comparative performance parameters. So basically, dimethyl ether as a standalone fuel is a clean burning fuel, which is the primary supporting factor for DME, and it can be sustainably produced, unlike LPG. And in commercial DME burners, the primary air inlet is low, so it is more suitable for higher altitude applications. The current commercial DME LPG burners are more efficient, and the combustion efficiency of DME is also again slightly higher than LPG. So these are the other factors. The heat loss has to be minimized. Obviously, that is applicable to all types of burners, irrespective of whether they are DME or LPG. The negative factor here is that DME is corrosive compared to LPG. So the selection of elastomers has to be done carefully, and the current materials which are in use for LPG are not suitable for 100% DME. Thank you. That DME is, while it may not supplant or replace LPG, would be an alternate fuel which will again be used for specific applications. Thank you. So we move on to the next presentation, and this is on carbon finance, clean cooking in rural India, and the speaker is Mr. Mohan Gurudath. He is a principal technical professional at KBR Engineering and Construction India Limited, Bangalore, specializing in rotating equipment and package systems for major oil and gas and petrochemical projects. He has over 17 years of experience across FEED, DPC and PMC phases. He has contributed to high-value international projects across all multinationals, and his expertise spans pumps, compressors, blowers, etc. So I welcome Mr. Mohan Gurudath to make his presentation. Thank you.
My topic is carbon financed clean cooking in rural India. Background: a significant share of rural households in India still depend on traditional fuels such as firewood, dung, agricultural residues for daily cooking. While these fuels are locally available, their use results in high level of indoor pollution. Prolonged exposure to cooking smoke is major health hazard, and it disproportionately affects women and young children who spends more time near the cooking area. From the environmental perspective, continued biomass contributes to deforestation and greenhouse gas emission due to inefficient combustion and unsustainable fuel harvesting. Despite large national efforts to expand access to clean cooking, sustained adoption remains a challenge. Affordability and refill costs and perceived economic value continue to limit long-term usage. This creates a clear need for scalable, transparent financing mechanism that complement existing policies such as PMUY and improves the economic case for clean cooking at household level. Problem statement: although clean cooking technologies are widely available, both upfront and recurring costs remain barrier for sustained adoption, particularly in rural and low-income households. Current subsidy-based models have achieved significant outreach, but they are constrained by fiscal limitation and may not be sufficient to ensure long-term usage without additional support. At the same time, emission reduction benefits achieved through clean cooking are not fully monetized or systematically captured. Carbon finance presents a complementary solution by converting verified emission reduction into a recurring revenue stream which support affordability and program sustainability. Conceptually, MRV and carbon revenue flow. This diagram represents the integrated view of how monitoring, reporting, verification process are structurally linked with carbon revenue generation and reinvestment in clean cooking programs. The upper section of the diagram represents MRV flow, which begins with baseline survey. At this stage, household level information is collected to establish prevailing cooking practices, including type of fuel used, stove efficiency, cooking frequency, and estimated greenhouse gas emission. This baseline forms a reference point against which future emission reductions are measured. Next stage is monitoring, where the adoption and actual use of clean cooking solutions are tracked over time. Monitoring relies on the combination of field surveys, usage log, and where feasible, simple digital or sensor based tool. The objective is to ensure clean cooking technology is being used consistently and as intended rather than merely distributed. Following monitoring, process moves to verification. In this step, independent third-party auditor review collected data, methodologies, and emission reduction calculation. Verification ensures that reported emission reductions are credible, conservative, and aligned with internationally accepted carbon accounting standards. Only after successful verification can emission reduction be formally recognized. Once verified, process transition into carbon revenue flow represented in the bottom section of the lower section of the diagram. Verified emission reductions are converted into certified carbon credits representing a quantified and audited climate benefits resulting from clean cooking intervention. These carbon credits are then sold into voluntary carbon markets to the organizations seeking to offset emissions. The sale generates a financial revenue which is channeled back into the program rather than treated as one-time gain. The final stage is reinvestment, which closes the loop, illustrated by dashed return arrow. Carbon revenue is reinvested to support the program sustainability by reducing household fuel cost, subsidizing stove maintenance or replacement, strengthening last mile delivery, and expanding program to additional household. The vertical structure with the feedback loop represent MRV and carbon finance are not linear, one-off process. Instead, the revenue reinvestment strengthen adoption and monitoring quality, which in turn improves the future emission reduction and carbon credit generation. This self-reinforcing cycle enhances affordability and accountability and long-term impact of clean cooking initiatives. A traditional versus clean cooking benefit summary. The above table summarizes the key household benefits observed when a family transitions from traditional biomass cooking to clean cooking using LPG. On the climate side, the traditional cooking typically results in about 2.8 tons of CO2 equivalent emission per household per year, mainly due to inefficient combustion of firewood. With LPG, emission reduces to 1 ton per year, giving a net reduction of about 1.8 to 1.9 tons annually. From the household economic perspective, annual cooking costs reduced from around rupees 8,500 to rupees 6,000. This reflects lower fuel quantities, reduced fuel stacking, and more efficient energy use, resulting in saving of approximately 2,500 rupees per year. Time savings are also significant. Traditional cooking requires roughly about 3 hours per day when fuel collection, stove preparation, and supervisions are involved. Clean cooking reduces this to about 2 hours per day, freeing up nearly 1 hour per day, particularly benefiting women. In terms of resources, traditional household consumes roughly about 2.5 to 3 tons of fuel wood per year. Clean cooking nearly eliminates this dependence, easing pressure on local biomass. Health improvements also significant. Indoor particle matter concentration reduces from nearly 300 micrograms per cubic meter to 70 micrograms per cubic meter with LPG, representing about 75 to 80% reduction in exposure. Finally, clean cooking creates a new revenue opportunity through carbon finance. Based on conservative assumption, each household can generate approximately 800 rupees to 1000 rupees per year in carbon revenue, which can be reinvested to support affordability and program scale up. Overall, this transition delivers integrated climate, health, economic, and social benefit at household level. These are conservative estimates aligned with national programs and international literature. Actual benefits can be higher with sustained usage. Policy relevance. The proposed approach is well aligned with national initiatives such as Pradhan Mantri Ujjwal Yojana and National Clean Cooking Mission. By enabling verified reduction, it directly supports India's national determined contribution and country's long-term net zero pathway. The model is designed to be scalable through public-private partnership, allowing government programs, private developers, and carbon markets to work together. Importantly, the framework is a technology agnostic and can be applied across LPG, electric cooking, biogas, and other emerging clean cooking solutions. In conclusion, carbon finance has a strong potential to strengthen the economics of clean cooking and reduce dependence on purely subsidy-driven models. The use of digital monitoring, reporting and verification improves transparency, credibility and confidence for all stakeholders. The proposed model delivers integrated climate, health and social benefits at household level. It provides a clear pathway from subsidy supported access towards market supported and self-sustaining clean cooking adoption. Most importantly, by improving the affordability and perceived value, it encourages sustained and long-term use of clean cooking solution. This approach positions clean cooking not only as a social intervention but as a climate and investment development. These are the key references. Thank you. Thanks.
Over the last couple of hours, there has been a lot of focus on making the clean cooking initiative sustainable. Next, we have Ms. Shruti Sharma. I believe she has 2 sessions. So, I'll finish both at one go and then you can carry on. She has 2 sessions. One is on clean cooking and climate mitigation through sustainable manner management, a verified carbon credit approach. And the second one is district level validation of comprehensive and lowered emissions assessment and reporting. Clear methodology in PMVY beneficiary households. Ms. Shruti Sharma is a research analyst with the Clean Air team at the Council on Energy, Environment and Water. Her work is centered around bolstering the clean cooking energy transition in India. With a strong focus on gender dynamics and behavioral interventions, she is dedicated to making a meaningful impact in sustainable energy and women empowerment. I welcome Ms. Sharma.
Thank you for that introduction, sir. And I'd just like to clarify one thing. I'm only here for one session. I believe that there was a slight change in my presentation title, and so that might have created the confusion. But yes, I'm very happy to welcome all of you to this session. Thank you for being here, and a very good afternoon. I'm Shruti, and I work at the Council on Energy, Environment and Water. Today I'm here to talk about a project that CEW has been undertaking in collaboration with CSIR Miri. Mr. Roshan Watore is a colleague of mine who also presented in the previous session and is in the audience, as well as Mr. Bhagat, Ajaykumar Bhagat ji, who's from DPCL and is a key partner on this endeavor. So with that, I'd like to start. And what I'm going to be talking about today is whether clean cooking can be both sustainable and financially viable through carbon markets. So we're all aware by this point that clean cooking sits at the intersection of climate action, health and energy access. And we're also aware, I hope some of us are at least, that carbon financing has been under great scrutiny over the last couple of years due to concerns with integrity, validity, reliability, etc. And efforts to improve frameworks that measure carbon emissions and verify projects to create robust carbon credits are underway. And it is under that umbrella that we're exploring the viability of LPG for carbon financing via the Pradhan Mantri Ujjwala program, with the idea being to cross-subsidize the Ujjwala subsidy that is provided to Ujjwala beneficiaries, thereby reducing financial pressure on the government and oil marketing companies, as well as helping these companies to also achieve better benchmarks in sustainability. So with that, yeah, this is pretty much what I just described in the previous slide. There are over-crediting risks and under-crediting risks that are associated with why carbon crediting for clean cooking has been a bit contentious over the last couple of years. Previous presenters also spoke about how clean cooking has been taken off the government list of industries that are going to be looked at in the Indian carbon markets framework, and the effort to sort of mainstream clean cooking and its potential, huge potential to generate carbon credits that are of good quality is something that we're interested in working towards. And so I won't get into a lot of the technical stuff information here, but just to keep it very high level, this is the overall credibility problem that exists with carbon crediting for clean cooking. This is the clear methodology that was created by a coalition called 4C, and there are various institutions of repute, including the United Nations, Clean Cooking Alliance, and multiple other institutions that have been working on this methodology. And the idea is to bring measurement of carbon credits for clean cooking under one unified framework, and this has been under review globally for the last 2 years. My colleagues and I have also been able to submit our comments to how each iteration of this methodology, which hasn't been formally published yet in its final version, and essentially contributing to that via scientific assessments and support. So, what we've been doing is, over the last 1 year, we've been doing a pre-pilot study. This has been done in 4 districts in India, and the pre-pilot has been structured in 2 phases. The first phase has looked at market and additionality testing, and this took place in a district in Maharashtra called Chandrapur and a district in Jharkhand called Chatra. And the idea was to verify the common criteria and whether this, again, being another term that basically pertains to how prevalent a clean cooking solution is in the community, and trying to establish whether there is an additionality that can be achieved via carbon finance. Only then is it credible. Otherwise, these are bogus credits that are severely overpriced and don't actually provide emissions reductions or global climate benefits as they claim to. And so the effort to go against that and improve the measurement, reporting, and verification process itself. In phase 2 of our pre-pilot study, we worked in Khandwa in Madhya Pradesh as well as Nandurbar in Maharashtra, and this was the emissions and exposure measurement phase, in which we collaborated with our scientists at CSI and NERI, and source emissions monitoring and exposure assessment was conducted for traditional cook stoves as well as LPG cook stoves, and also the improved cook stove that Roshan was speaking about earlier, the power cook stove. This again pertains to some of the barriers that have made establishing the additionality part of carbon finance a little bit challenging, and these are the parts that require stringent monitoring, reporting, and verification to ensure quality carbon credits. So this talks about why we started our pre-pilot in Chandrapur and Chatra, but then moved to Nandurbar and Khandwa in MP and Maharashtra for our project. Some results, some findings from our from phase 1 and phase 2 of our pre-pilot. Phase 1 was a market reality check to understand the common practice requirement, as mentioned earlier, and the findings were very interesting. While Chandrapur does have quite a significant amount of population that's primarily using clean fuels, including LPG, the same was not observed in Chatra. In Chatra, the rate of access to clean cooking is very, very low, and there are several households that have not received an initial connection for the Ujjwala connection, and or else are not using cylinders at all, and so they are primarily still cooking with polluting fuels. Some other findings also reveal that there is very low doorstep delivery of cylinders taking place. Doorstep delivery of cylinders is somewhat mandated by the concerned regulatory body, and this is to prevent problems with last mile access to LPG, making LPG reach to the doorstep of households to reduce friction in that being a preferred cooking solution. What we also found was that Ujjwala beneficiaries exhibit a significantly lower willingness to pay for exclusive use of LPG, which means that carbon finance again becomes very pressing to mitigate this concern and to support the subsidy that the government is already providing via their coffers. The emissions and exposure monitoring phase in Khandwa and Nandurbar was conducted using the source emissions monitoring system, which has been pioneered by Roshan sitting in the audience. And this was the process via which the emissions monitoring and exposure measurement was taking place. So in figure 3, you can see that this is a traditional cooking setup, and the source emissions monitoring is taking place in that setup. And in the next figure on the right side, you can see that the lady is cooking with LPG and the source emissions monitoring is being conducted to understand how much emission savings can be generated using LPG, which is absolutely crucial to carbon finance. So the verdict is that our preliminary results so far show that LPG delivers large and consistent reductions at the source level and at the microenvironment level. The microenvironment level refers to the indoor environment in which the cook is cooking. And if we are to assume that the cook is cooking indoors and not outdoors. So the microenvironment is the room in which a cook is cooking, and so that also generates indoor air pollution. That space is where indoor air pollution is constricted, and that is where the cook faces exposure to the polluting fuel, the polluting gases that are released because of cooking with solid fuels. There are several climate co-benefits that we also found out as a part of the findings of the study. And we also presented at the India Energy Week in 2024, which was an earlier iteration of the same project, where we discussed how the LPG carbon crediting framework could be improved. This was before the clear methodology that I was referring to earlier came into picture. And we see that there are about 57 kg CO2 equivalent emissions that an LPG cylinder emits, while baseline emissions range between 500 to 700 kg CO2 equivalents. So the net mitigation falls between the range of 450 to 725 kg carbon dioxide equivalents, which is at another jargonistic term I'm going to throw you away, FNRB, which is fractional of non-renewable biomass. This is a core metric that is used in carbon financing, and it's used in the input. I'm going to quickly rush to the rest of this because I'm towards the end of my time. But there are also significant co-benefits for health that we've also noted and observed. And our preliminary findings also show that in terms of infections of the chest and the heart and the brain, as we can see listed over here, are significantly mitigated, or let's say they are significantly avoided with the use of clean fuels like LPG. So the preventable burden figures that you see on the slide refer to how much of a health burden is avoided by the use of these clean fuels. So this is how clean cooking pertains to SDGs that are pertaining to health, gender, energy access, forests, multiple such SDGs. I'm going to quickly skip this slide because I am short on time and it is more jargon heavy. If anybody has any questions or wants to discuss something on these lines, I'd be happy to do that after the session. And finally, this is a brief timeline of what we aim to do with this pilot program that we will be launching in association with Bharat Petroleum and CSIR Media. We would like to understand what is the feasibility of these measurement approaches for carbon financing for clean cooking, which basically means that to measure and verify and report these numbers so that credible carbon finance can be generated is a costly and time-intensive and money-intensive affair. So how much of it is achievable in a feasible manner is something that we're looking to understand. We're also trying to, of course, come at conservative estimates and not inflated estimates of emissions reductions so that our quality of credits is high and it's able to sell in the market eventually. And we're also trying to understand what LPG-based interventions don't meet in terms of additionality. So we are not only trying to explore the viability of LPG for carbon finance, but we're also trying to do an independent assessment of how good enough that is as an option for carbon finance. And of course, this has a major impact on household exposure to air pollutants. So because I work in the clean air team at my organization, this is also something that we're very interested in looking at and measuring. And over the next 12 months, we will be going from we've already completed our pre-pilot phase. We will be doing our baseline surveys, measurement, tracking, reporting, verification. And in a year's time, we hope to be able to come out with some solid synthesis and policy outputs that could inform the government, hopefully, and oil marketing companies in how carbon finance can be linked to clean cooking. And with that, I come to the end of my time here. This is a message I'd like to leave you all with. If there's one thing you remember from this presentation, maybe it could be that. And thank you so much for your time. Thank you for being a great audience.
We move on to the next session. This is Desert to Hot Serve Deserts, Solar Sand Batteries for Green Cooking Revolution. The session is being taken by Mr. Suman Tutoo, who is currently working as a general manager with IndianOil Corporation. He is actively engaged in advanced research on clean energy applications with a particular focus on innovation in clean cooking domain. His current work explores the integration of solar-based cooking systems with sand battery thermal storage to address challenges of intermittency and to enable round-the-clock energy availability. Mr. Suman Tutoo, please.
Good afternoon to all. I am Suman Tutoo and I am joined by one of my colleagues, Sudhanshu. And it's a paper on the desert to hot deserts, solar sand for green revolution. Today, we are here to present a unique innovative solution that is solar powered sand batteries for clean cooking. This per se is a solution that is born from the abundant sunshine and the abundant sand we have. But at the same time, we have to think in terms of its viability, whether it's fitting in our health issues which are cropping from burning of fossil fuels, and why it is urgent now. Let me walk you through the presentation flow, where we will be looking at the problem we are trying to solve, that is clean cooking crisis with solar powered sand batteries. With this background, we'll look how this solution, how this innovation has come to foreplay. We'll take the rural and the urban scenarios where the fuel, various types of fuels are being used, and we will look at the LPG paradox, how that increased excess has not been able to solve the problem of clean cooking per se. We'll also look at the ingredients of this solution. First, we'll look at the possibility which sand provides us and the solution which we bring about using this sand for clean cooking. Then we'll look at the economics, benefits, and the challenges we have as on now, and the implementation strategy, how we'll be moving to implement such solutions. And lastly, we'll summarize what it brings to us. My dear friends, it is not just the technology what we are talking today, it's just a path to energy dignity. So allow me to share the Indian clean cooking crisis. Let us understand this. I want to start with a very simple question. what fuel you used for your preparation of the breakfast today? Obviously, most of us would agree to this, that it must be LPG or natural gas or the electricity per se. So, but this is not the complete story of it, because half of India is still have energized their breakfast through smoke, soot processes, through use of cow dung, wood pellets and other means. So the situation is very grim. Grim in the sense that in household we are losing around 6 lakh deaths are happening every year. And there is a very harsh impact on the environment. As you can see, 30 million tons of CO2 are getting emitted. Now imagine a scenario wherein you have everything at your Indian geography, be it abundant sunlight, be it abundant sand, and what we have to do, we have to integrate both of them to provide a solution so that the clean cooking is available even during sunset, after sunset, and also during the periods when there are rains. So no sunset is available. So here we have a solution. This is what this solution is aiming at to solve this crisis. Before we dive into this, let us understand how fuel is being used in the rural as well as the urban sectors, because they are by far in stark contrast to each other. While urban fuel is almost fully based on clean fuels, around 93%, rural India is still babbling at 47% dependence on biomass. So despite progress in LPG, what we see in LPG distribution, the sustained adoption is still missing. So this rural divide reflects how we do this sand battery innovation to create an affordability, accessibility and cultural pattern. Our solution specifically addresses this gap. Let us understand the LPG paradox. Here, you all know that the access to LPG has increased drastically, especially through the Pradhan Mantri Ujjwal Yojana program. But exclusive LPG has not been met. Around 38%, as I told, household continues to be on the biomass, along with LPG, a practice called fuel stacking. So why? Because LPG is still expensive for our rural household, and India is still importing 50 to 55% of its LPG. So this creates both domestic affordability issues along with the national energy vulnerability. So let us look at the first ingredient, that is sand. So what is beauty about this sand? So this is the heart of this technology. Silica sand, as you know, is abundant, cheap, safe and durable. It can store heat up to 400 to 1000 degrees with efficiencies to 90 to 95%. So it retains heat for weeks together if provided a very good insulation. So all these systems can last around 30 to 40 years with very minimal maintenance. We can say no maintenance at all. So this makes sand a perfect medium for long duration heat storage. Now let us understand how we are doing it, how this sand battery works. This is a thermal storage battery. It is not a chemical battery per se. Solar power heats sand to a high temperature, and then heat is stored safely and released for cooking whenever it is needed. So here it is trying to solve the biggest barrier of solar cooking, that is intermittency. Users get heat even at night or on cloudy days. So it is safe non-toxic and specially suited to replace biomass for continuous cooking. So let us look at the economics. The economics, what we have calculated is on a 48 hours backup we have for a storage. So on that backup, we have created two scenarios, which is on the standalone scenario and the commercialized scenario. At household level, the capex seems to be pretty high at this point of time, around 4.5 to 6 lakh. But on the community scale hubs, the cost drops dramatically to 85,000 to 2 lakh per household. So zero operational cost is what it makes attractive in a long run. However, scaling this as a shared infrastructure in terms of in apartments, community kitchens, hotels, makes the economic more viable. Let us understand now how that reliability of 24/7 gets created. India per se has abundant solar power and solar energy, but people need cooking when they choose to cook, not when the sun shines. So sand batteries convert this intermittent solar energy reliably heat supply to the household or to the hotels. So here reliability is driving this innovation. So reliability is driving this adoption of this innovation. So once people trust this, that clean cooking is always available, fuel stacking will definitely end. This per se is not only the solution, innovation, but it has an impact on the national front as well. The benefits extend beyond households. Here, what we are doing is replacing solid fuel cuts into a major portion of CNG emissions. So huge cuts will be happening in CNG cuts. We will reduce the LPG imports drastically, and using sand, which is an indigenous material, will support circular economy also. So this is a climate, health and strategic opportunity for India to switch into this solution. But my dear friends, you will say, there will be challenges. Yes, there are challenges. We are realistic about that. So what challenges we'll look at are on three fronts, that is technical, economic and socio-commercial. On the technical, there are challenges like optimizing heat transfer interfaces. On economics, LPG subsidies make alternative innovations hard to justify initially because a lot of subsidies are happening. And in socio-cultural challenges, habits that solar will not work in night, perceptions and trust in solar solutions. But none of these challenges are insurmountable. They can be addressed and addressed fast. So we propose a three-pronged strategy for overcoming these barriers. First is invest in R&D to make the cooking interfaces fast and user-friendly. Second, support this adoption through financial innovations like VGF for community hubs, low interest loans, or pay as you cook methodology. So it can be used that way for the community kitchen also. Third, we have to build trust. This is a new innovation. You have to build trust through awareness campaigns, transitional policies, and respect the household realities which our women folks are facing because of not adopting to this technology. So what should be our roadmap ahead? So we have created a four-step roadmap. First is, let us start with pilot projects. Pilot projects where solar insolation is high, start with Gujarat and Rajasthan. Where parallelly, we have to develop certain standards and certifications for safety and performance. Create a regulatory and financial ecosystems, carbon credits, loans and VGFs. Use pilot findings, whatever you get from the pilot findings, to enable mass scale adoption. We have to market it very hard across India. So my dear friends, it is not the theoretical concept. This is executable right now. So the solution, entire solution is summarized this way. So what is the problem? Public health crisis, environmental emissions, and energy dependency, because LPG has to be exported. Then what is the solution? We have the solution: a safe, durable, indigenous solar sand battery. What will be the impact? What will be the impact on this? Fuel poverty, elimination, and decarbonization at a larger scale. What is the opportunity for all of us? Opportunity is commercial viability and strategic national value. That this technology per se aligns perfectly with India's clean energy ambition. So this technology is a cornerstone technology for India's clean energy future. It is not just a cooking solution. It is a solution for India's clean energy. It delivers climate, health, and economic benefits simultaneously. It is scalable, resilient, and built on India's natural strengths: abundant sunshine, abundant sand. So the time is now for the adoption. So let's adopt. With the right intent and the policy support, India can lead the world in this thermal energy innovation. Last but not least, my contributors, one of them is on the right hand side, Mr. Sudhanshu and Joshi, who have contributed to create this type of solution with me. So lastly, I want to thank all of you, but I hope this session inspires a meaningful discussion around how India can adopt durable, indigenous, and scalable solution using sand as for clean energy. Thank you for patient hearing.
Thank you, Mr. Suman Tutoo and the co-authors. I have a couple of questions here. I see that you are not given a photo or a technical details of the battery itself. So is it actually made, or is it still in the... We have now the last speaker of the session, Mr. Mathur, on advancing clean cooking through mandatory efficiency standards in India. The speaker is Mr. Jatin Mathur. He is an associate with CLASP. He is an energy and climate policy professional who is focused on advancing clean energy access and appliance efficiency and climate finance across India and South Asia. He specializes in designing and implementing user-centric pilots, supporting energy efficiency programs, and contributing to national strategies that strengthen energy resilience. Welcome Mr. Mathur to make his presentation.
Good afternoon to all. Before I begin my presentation, I would like to make a comment. The word clean in clean cooking is not an absolute word. We always use clean in context with other thing. For example, LPG is much better than biomass. Electric cooking is much better than LPG, and so on and so forth, right? I am going to diverge a bit and talk more about electric cooking, moving from LPG and biomass and improved cook stoves to modern energy-based cooking services such as electric cooking and induction-based cooking. I work at CLASP. Yeah. So I work at CLASP. CLASP is an international non-profit working in energy efficiency of appliances in India and across the world. In India, we particularly work with Bureau of Energy Efficiency to support their standards and labeling program. And this work is one of the findings, one of the outcomes of that work. So what is the status of clean cooking across the world? I mean, a lot of panelists have already talked about it, but just to summarize that, 2.3 billion people still rely on dirty fuel. Even with pace of current efforts, 1.7 billion will still lack access to clean cooking by 2030. 1.7 billion people will still lack access. We know that cooking with dirty fuel leads to air pollution, which in turn causes 3.7 million premature deaths across the world annually. India, with schemes like PM Ujjwala Yojana and 100% electrification, paves the way for scaling access to clean cooking for millions of people in the country. Specifically, urbanization drives demand for modern cooking services due to access to reliable power alongside the affordability considerations. There is a policy opportunity to help converge technological innovation, market ecosystem, and industry engagement to scale clean cooking transitions through energy efficiency policies. Before I talk about the study, let me provide a brief overview of institutional framework for energy efficiency. When it comes to who regulates energy efficiency of appliances in India, two public institutions comes in mind. We have the Bureau of Indian Standards or BIS and Bureau of Energy Efficiency, which is BEE. Members of whom, BIS is a national body which regulates the quality, safety, performance and reliability of appliances in India. They set energy performance benchmarks, quality control order for compliance and so on and so forth. On the other hand, we have Bureau of Energy Efficiency, BEE, another statutory body responsible to reduce energy intensity of the Indian economy by improving the average energy efficiency of the market. They set energy. It is also the agency primarily responsible to oversee the standards and labeling program. The labeling program is the label which you see at the appliances like 5-star, 4-star, 3-star label. Bureau of Energy Efficiency sets minimum energy performance standards, which is MEPS, as well as star rating bands to guide consumers on energy savings potential of various appliances, which includes consumer appliances like AC, fans, as well as industry appliances like boilers and motors. Induction cooktops, Induction cooktops are the only primary e-cooking appliance that is covered under the standards and labeling program. We do not have any other electric modern energy appliance covered by the label program. We conducted rigorous testing of randomly selected appliances from the market and get it tested as per IS 19014-2022. The induction cooktop program was launched in 2022 under the voluntary status basis the recommendations provided by CLASP to BE in 2021. Early 2025, we conducted another set of testing to understand the current levels of efficiency in the market, if there was any progress in the appliances. Based on the findings, CLASP recommended Bureau of Energy Efficiencies to make the SNL program mandatory of induction cooktops with slight revision in one of the pre-qualification criteria. The program is set to cumulatively save energy of 2.7 billion units by 2030. Good news is that our energy efficiency policy is now at par with global policies, European Union as well as China. One of the programs that helped us inform this policy development process is the Global Leap Awards conducted by CLASP through Efficiency for Access. The program is targeted to identify best performing energy efficient appliances in underserved regions. In 2024, we conducted the competition in India and Kenya where 22 users tested induction cooktops through controlled cooking tests as well as usability testing in their homes, in order to assess cooking performance, behavioral challenges, other set of feedbacks on the design of induction cooktops. The program informed user-centered design of the technology alongside quality assurance to enhance trust among consumers, investors, and policymakers. To complement this, a consumer guide was published with 4 induction cooktops recognized across different categories. So mind you, brands like Prestige, the induction cooktops from EESL was participated in this competition. These are some of the photographs that you can see from our citizen scientists who tested these products at their homes during controlled cooking tests, both in Kenya as well as in India. The findings from these competitions informed the policy development process that CLASP recommended to Bureau of Energy Efficiency. So what did we learn? Apart from the numbers related to energy savings and emissions, of course, we have a couple of things that we understood about the market, which are particularly relevant globally. Number one, standards and policies are vital in driving market transformation of consumer appliances. Without proper regulatory frameworks in place, OEMs and brands lack incentives and the push to improve efficiency and performance, of course. Limited testing infrastructure creates hindrance for compliance and market feedback activities. And of course, mandatory policies allows innovation and competitiveness across the industry. I would like to announce that CLASP is now a Tier 1 implementer of NEXT program, which is the Modern Energy Cooking Services program funded by UK FCDO. And will be leading activities on venture building, market shaping, and research on clean cooking transition in India, Nepal, and Indonesia, among South Asian countries. To summarize, India's cooking program have the potential to inform global transition discourse, as we have seen. Policies like standards and labeling program for modern energy appliances will significantly reduce energy consumption, potentially leads to energy savings for the consumers, and help cultivate competitiveness within the industry for that particular 5-star rated label. So good news is that the mandatory policy will be active from July 2026, and I hope that whoever is buying induction cooktops from the market, please buy 4-star or 5-star products. Thank you.
Thank you, Mr. Mathur. So that way, I'm very grateful to the panelists who have all contributed. Thank you very much.